All right, I know today we're spending our time finishing up the assignments for this week, but I wanted to offer you some extra credit. In the online assignments, I had said that you should copy down the chart. It would be handy to have, but I am now going to, I'll give you extra credit for it if you copy down the chart. So this is what I would like on the chart. Based on the diagrams that we drew earlier, there are 5 different scenarios for concave mirrors. There's one scenario for plane mirrors, an image in a plane mirror, and there's one scenario for convex mirrors. And the distance of our object, or our object location, our image location, if the image is real or virtual, if it's upright or inverted, if it's magnified or enlarged or the same size, if the distance of my object is positive, if the distance or negative, if the distance of my image is positive or negative, the height of my object is positive or negative, the height of my image is positive or negative, and the focal length is positive or negative. So I'm going to fill in a few of these for you to show you what I'm expecting, and if you want some extra credit, I will give you some if you finish the rest of this chart. So for concave mirrors, there's 5 scenarios. Because I'm weird like this, I would want them to go in order. So the first one would end up being if my object is located beyond C, and then we learned that my image is located between C and F. And we know that it's real and that it's inverted and that it's reduced or smaller. The distance of my object is positive, and actually the distance of my object will always be positive. It's going to be in front of the mirror, so it'll always have a positive value. The distance of my image in this case is also going to be positive because I have a real image. So if I have a real image, the distance of my image will be positive. The height of my object, this will also always be positive, so this whole column can be positive. And the height of my image, because I'm inverted, the height of my image is going to be negative, and the focal length for concave mirrors is positive. It's in front of the mirror. So this is what I'm expecting for all of them. So there's the 5 different scenarios for concave. For plane mirrors, right, the object is just going to be in front of the mirror. Right, we're not specific about our distance. Same thing with convex mirrors, it's just in front. And then our image is going to be behind the mirror. Right, because it's behind the mirror, it's virtual. Same thing with convex, right behind and virtual. We talked about in class yesterday that, side note here, for plane mirrors do not have a focal length or a focal distance. But for convex mirrors, because the focal length is behind the mirror, it's identified as negative. And same thing with the image distance. For a convex mirror is always going to be negative. So even if it doesn't say negative in the word problem, you have to identify it as negative because it's the image formed in a convex mirror. Our plane mirrors, right, the image is behind the mirror, so it's also going to be negative. We didn't do any math for plane mirrors because the height is the same and the distance is the same, so there's no real equation to use for plane mirrors. But this is what I'm expecting for the 5 different scenarios for concave, 1 scenario for plane, 1 scenario for convex. And this will be handy for your quiz on Monday, so it serves a dual purpose, extra credit and a lot of information in a small spot for your quiz.